What if I told you Detroit Diesel once built an engine so massive it made the 8V92 look like a toy? Most diesel fans know the 8V92, 12V71, or even the 16V149. But deep in the company's lineup was something even bigger, an engineering outlier designed for the most extreme applications. Before we talk about that monster, we need to understand where it came from. By the mid-1960s, Detroit Diesel had already cemented itself as a leader in two-stroke diesel engines with its successful Series 71 platform. The Series 92 would follow in 1974, further solidifying its position. These engines were common across 18-wheelers, military vehicles, and industrial applications. But a new problem was emerging. For extremely high-demand environments such as ocean-going vessels, offshore oil rigs, and massive industrial pumps, the available engines simply didn't produce enough continuous power. The industry was shifting toward more horsepower and torque in tighter footprints, and Detroit Diesel needed something that could meet those needs without abandoning its proven two-stroke design. Enter the Series 149. This engine was named like its predecessors, by the cubic inches displaced per cylinder. In this case, each cylinder measured 149 cubic inches, or about 2.44 liters. That was nearly double the displacement of a single cylinder in the Series 71, and over 50% more than one from the Series 92. It wasn't just a bigger engine, it was a response to a specific power gap in the diesel market. While the 71 and 92 were still viable for mid-range applications, customers operating tugboats, dredgers, and other marine vessels needed more. Operators in those industries weren't looking for quick bursts of acceleration. They needed engines that could run near peak load for hours or days at a time. In oil field services, for example, rigs relied on continuous power for drilling and pumping. In marine applications, vessels traveling long distances in open water couldn't afford downtime or performance drop-offs. This kind of usage required engines that could produce massive amounts of torque at low to mid RPMs, and do so reliably under heavy stress. The Series 71, though iconic, was designed during the 1930s and had already been stretched to its performance limits by the post-war years. The Series 92, while a step up in power density, still wasn't large enough in displacement for emerging industrial and marine standards. Detroit Diesel needed a new platform that could handle high horsepower applications without resorting to entirely new engineering principles. Their engineers started with what they knew: the two-stroke cycle. This configuration, already used across all their product lines, allowed them to achieve a high power-to-weight ratio. Two-stroke engines produce a power stroke every revolution, unlike four-strokes, which need 2 revolutions per cycle. The 149 series carried this tradition forward, using uniflow scavenging with blower-assisted air delivery to purge exhaust gases and fill the cylinder with fresh air. Like the Series 71 and 92, it relied on a roots blower to manage air movement, but here it was optionally paired with turbochargers to improve efficiency and keep intake pressures high across the RPM range. Detroit also maintained its philosophy of field serviceability. Just like the Series 71 and 92, the 149 used unit fuel injectors and individual cylinder heads. These decisions weren't just engineering conveniences, they were logistical choices. Mechanics working offshore or in remote environments needed engines that could be repaired without special tools or long downtimes. Keeping a consistent parts language across engine families allowed Detroit to serve these demanding markets without retooling every time a customer wanted more power. By using modular construction, they were able to scale the Series 149 into V configurations almost immediately. The first variant to hit production was the 12V149, released in 1966. It offered a massive increase in output over the company's earlier engines and found immediate uptake in marine markets. The layout placed 6 cylinders on each side of a 60-degree V block. It was followed in 1974 by the even larger 16V149, expanding both power and market reach. Both engines featured individual cylinder heads, one per cylinder, simplifying maintenance and allowing for rapid field repair, something Detroit always emphasized. This entire approach, modular blocks, air-scavenged two-stroke combustion, unit injectors, was a deliberate evolution rather than a reinvention. The goal was to create something that pushed the limits of horsepower but retained the serviceability that Detroit's engines were known for. Unlike competitors who pursued more exotic technologies or complex configurations, Detroit doubled down on what had made it successful. Straightforward mechanics, robust materials, and a platform that could be scaled both up and down depending on need. As demand grew, it became clear there was room for even more power. That's where the 20V149 comes in, an engine series that would define a new ceiling in two-stroke diesel output. The Detroit Diesel 20V149 wasn't just a scaled-up engine. It was a mechanical colossus that pushed the boundaries of what a two-stroke diesel could do. With a total displacement of 2,980 cubic inches or 48.8 liters, this engine was engineered for one purpose: deliver enormous, continuous power under brutal operating conditions. The architecture was a 20-cylinder V configuration, but it wasn't a simple two-bank layout. The engine actually used three separate blocks, two 6-cylinder banks flanking a central 8-cylinder section. This composite design made the engine more serviceable and modular, while allowing Detroit to adapt existing tooling and manufacturing setups. The V-angle followed Detroit's traditional 60-degree layout, preserving balance and smoothness. Each cylinder displaced 149 cubic inches with a bore and stroke of 5.75 by 5.75 inches. That square stroke ratio meant uniform combustion pressures and consistent power delivery, which were crucial for long-duty cycles in marine and industrial environments. The compression ratio was 17:1 for naturally aspirated versions and 16:1 for turbocharged and intercooled variants. Being a two-stroke, the engine delivered a power stroke every revolution. This allowed for much higher power density compared to four-stroke diesels. But to make that work, Detroit had to solve for massive airflow needs. The 20V149 used a combination of 3 Roots-type blowers and 6 turbochargers. The blowers were responsible for scavenging, clearing out exhaust gases and filling the cylinder with fresh air, while the turbochargers ensured that intake pressures remained high, especially under load. Intercoolers were also fitted to reduce intake air temperatures, improving efficiency and reducing the risk of detonation. Fuel was delivered through Detroit's signature unit injectors, one per cylinder. These were camshaft-driven and mechanically timed, allowing for extremely precise fuel delivery even across 20 combustion chambers. The injectors were managed by a governor system that balanced power output with engine load, ensuring consistent performance under varying demands. Thermal management was another massive undertaking. This engine used a high-capacity water cooling system with dual water pumps to circulate coolant through all 3 blocks. Heat exchangers and auxiliary coolers were often added depending on the installation environment. For lubrication, it relied on a wet sump system with a high-volume oil pump. Oil coolers and filtration units ensured that the lubricating system could handle the thermal and mechanical stresses of 24/7 operation. Noise and emissions were unavoidable byproducts of a two-stroke of this scale. The exhaust note of a 20V149 underload wasn't just loud, it was seismic. With exhaust pulses from 20 cylinders firing every revolution, the sound pressure levels were intense. In confined marine engine rooms or enclosed pump stations, this required extensive baffling and insulation. As far as emissions, it predated modern standards, meaning it would not meet today's regulatory limits without significant modification. Despite its size, Detroit built the 20V149 with field service in mind. Each cylinder had its own head, making individual cylinder maintenance easier. Inspection ports and access panels allowed for in-place servicing of injectors, timing, and other components. Many parts, injectors, governors, filters, were shared with other Detroit engine families, keeping maintenance costs lower and logistics easier. Performance-wise, the numbers were staggering. Horsepower ratings peaked at over 2,900 in turbocharged and intercooled form, with torque output exceeding 7,000 pound-feet. It operated best at a rated speed of around 1,800 RPM, well below the red line. Two-stroke diesels like the 20V149 didn't rev high. The perception came from their firing once per revolution, which made them sound faster and more frantic than they actually were. Many were tuned for long-haul continuous duty at even lower speeds, prioritizing durability and efficiency. Fuel consumption varied, but under full load, this engine could easily burn hundreds of gallons of diesel per day. In essence, the 20V149 was a purely industrial solution. It wasn't built for elegance or mass market appeal. It was built to do a job that few engines could handle. The Detroit Diesel 20V149 wasn't an engine you'd find in a common truck or city bus. It lived in environments where only the most powerful and durable engines could survive. Because of its sheer size, fuel consumption, and output, it was reserved for applications that demanded unrelenting performance under extreme loads, often in places where maintenance crews were far from home, and downtime wasn't an option. In the marine world, it found its most natural habitat. Tugboats, commercial fishing vessels, and dredgers often ran engines like these for hours, sometimes days without rest. Their need for high torque at low RPM made the 20V149 ideal for propeller-driven watercraft. Detroit's two-stroke layout allowed for a more power-dense package compared to many four-stroke alternatives, which meant higher output could be achieved without requiring significantly larger engine rooms. In many vessels, these engines were mounted in twin setups, providing both redundancy and power. Gear reduction systems were used to convert the engine's RPMs into usable thrust at the propeller, with some vessels running transmissions specifically built around the engine's torque characteristics. Beyond tugboats, it was used in offshore support vessels and even large commercial fishing boats operating primarily in the open ocean. In these cases, the engine's durability and ease of maintenance were critical. Crews needed to keep the ship moving, even if it meant doing repairs at sea. The modular layout and shared parts with other Detroit engines helped make that possible. Another major use case was in the oil field. High-pressure pumps used for hydraulic fracturing, or fracking, required immense amounts of continuous horsepower to inject fluid into subterranean rock. The 20V149, with its enormous displacement and proven track record in marine environments, was a natural fit. Mounted on mobile skids or inside enclosed pump trailers, these engines were used to power compressors and pumps day and night in the harshest environments. Here again, serviceability was key. A team of mechanics in a remote oil patch could perform injector replacements, cooling system repairs, and even major overhauls without shipping the engine out to a specialized facility. In the industrial world, it also served in high-volume water pumping applications. In regions prone to flooding, municipalities installed massive pump stations, equipped with engines like the 20V149 to move millions of gallons per hour. The same applied to irrigation systems in agriculture, especially in areas where electrical infrastructure wasn't viable. These engines could run for long periods, often unattended, with only periodic checks from maintenance staff. Generator sets were another home for this engine. These weren't your average backup power units. They were mission-critical systems used in mining camps, remote construction projects, or emergency power setups for infrastructure. Some were even installed in hardened facilities as part of civil defense planning during the Cold War. With fuel available and regular maintenance, these engines could supply consistent, uninterrupted power. Though rare, there were a few instances of the 20V149 being tested in locomotives or specialized mining vehicles. These were generally prototypes or short-run builds. In most cases, the engine's weight emissions profile, and maintenance requirements made it unsuitable for widespread use in mobile land-based vehicles. It was simply too big and too fuel-hungry for overland duty, especially once emission standards started tightening in the late 1980s. Custom integration was the rule, not the exception. Whether in a marine hull or on a steel frame for a pump rig, every installation of the 20V149 was different. Detroit Diesel provided base engines, but most final applications were configured by integrators like MTU, Allison Transmission, or specialized marine builders. These companies would design bespoke cooling systems, air filtration setups, and control panels tailored to the environment. Many engines were painted and badged according to the outfit that commissioned the build, which can make identification tricky today. Of course, there were challenges. The 20V149 required diligent maintenance. Filters, injectors, turbochargers, and cooling systems all needed frequent inspection and servicing. Its fuel consumption was immense, which made it economically viable only in industries where fuel costs were secondary to uptime. And its noise and emissions made it unsuitable for use in many populated or environmentally sensitive areas. Still, in the right hands and the right environment, it was a beast. It delivered raw, unrelenting power in ways that few other engines could match. And it did it reliably. That's why even today you'll still find a few 20V149s thundering away in marine docks, oil fields, or behind tall chain-link fences guarding critical infrastructure. By the early 1990s, the writing was on the wall for engines like the 20V149. It wasn't a failure, far from it, but diesel technology was changing fast, and the demands of industry were shifting just as quickly. The very things that had made this engine a powerhouse, its raw displacement, mechanical simplicity, and fuel consumption, were becoming liabilities. One of the biggest drivers of its phase-out was regulation. In the United States, the Environmental Protection Agency began rolling out tighter emission standards starting in the late 1980s. These regulations targeted the very aspects of two-stroke diesels that made them powerful: unburned hydrocarbons, high particulate output, and nitrogen oxides. Retrofitting a 20V149 to meet even the earliest Tier 1 standards wasn't just expensive, it was nearly impossible without gutting its performance. At the same time, competition was heating up. Manufacturers like Cummins, Caterpillar, and later MTU and Volvo were introducing more efficient four-stroke diesels with electronic fuel injection and digital engine management. These engines produced nearly as much power but burned less fuel, made less noise, and ran cleaner. They also required fewer overhauls, something any operations manager or government agency cared about. In contrast, the 20V149 still relied on mechanical injectors and analog governors. Bulletproof, yes, but also outdated. As a result, demand for the engine dwindled. Detroit Diesel quietly stopped production of the Series 149 line, and with it, the 20-cylinder variant disappeared from new builds. Many units were retired, sold off, or replaced with more modern power plants. But for some, the 20V149 never went out of style. Among marine engineers, old-school diesel mechanics, and hardcore engine enthusiasts, it became something of a legend. It was the kind of engine people didn't just use, they remembered. The sound at idle is unmistakable, a deep, rhythmic rumble that only a high-cylinder count two-stroke could produce. Some enthusiasts even seek out old units to restore. You'll find some at diesel meets, collector expos, and on YouTube channels dedicated to heavy machinery. The restoration process is never easy. Parts aren't exactly lining the shelves anymore. But there are still enough used components in circulation to keep a few of these monsters alive. In many cases, parts are custom machined or salvaged from derelict marine engines or retired fracking rigs. Not all survivors are showpieces. A handful of 20V149s are still in active service, humming away in pump houses, generator stations, or dry docks. Some are used as backup units for primary systems, only fired up during peak demand or emergencies. Others are held in reserve by facilities that never bothered to upgrade because, well, the old Detroit still works. It's not uncommon for these engines to run only a few hours a month, but when they're needed, they always start. What makes these remaining engines even more impressive is the fact that most of them are running well beyond their intended service life. Detroit didn't design it to last half a century, yet some of these units are pushing 50 years of continuous operation. That longevity is a testament to the build quality, but also to the people who maintain them. Keeping this engine alive today takes serious know-how, patience, and a deep appreciation for the mechanical. In the broader history of diesel engines, the 20 V149 holds a strange but respected place. It represents the high watermark of Detroit diesel's mechanical era.